The very first accessory what we are about to see is nothing but a gate valve. So now you know this, what exactly is a gate valve online. A gate valve is something which is not a regulating valve. So what exactly is a gate valve? Yes, Mr.
Sir, please repeat about the adopter. What is adopter? I don't understand.
Okay, we'll discuss that. Don't worry. Okay, I'll give you a more technical. And someone just said me that he's having a drawing. Let it come. I'll show you. Okay, we'll read that.
Okay, sir.
If not, remind me tomorrow. Will be again if I try to find out more good stuff so that I can show you. Okay, adapter is being installed over here, and this is the reason why it is installed. Okay. So now let's move on with the accessories. Very first accessories, and we know this. What are the accessories? Accessories is something where we use. I mean, it's some devices you can say where you can regulate the pressure, or you can measure the pressure, or you can measure the temperature. These are all accessories like pressure gauge and thermometer, a number of things over here like valves and all this. These all comes under accessories over here. So we are seeing about the accessories and the pipe and all this. So the most, first of all, we'll be seeing is a gate valve. So gate valve is nothing. We have seen a gate valve again in terms of tap. The same kind of valve is being installed in the tap, and faucet angle valve. I hope you guys remember. So this is how exactly a gate valve looks like. For example, this is a cylinder, or this is a sphere or wheel, you can say. When I rotate in clockwise or anti-clockwise, for example, as if now according to my side, if I rotate this in anti-clockwise like this, okay, this will be lifting up. And if I see from here, so I'm having a small gate or a welded sheet over there, small sheet or a welded gate kind of thing over here. It lifts slightly. And from here, for example, this is the inlet and this is the outlet of the water. So the water goes and moves on over here. For example, this is the most important thing whenever we are having a gate valve or IV. I can say IVs are like ball valves and one more IV. Why IV? Isolating valve. That is, it should be, all IVs should be completely open or completely closed. Isolating valve. It is isolated. Yes or no? Not a regulating. Right.
Yes, sir.
The gate valve is a valve which is being utilized, a valve utilizing a gate, usually wedge shape, that allows the fluid when the gate is lifted from the. Always remember, this would be again used for the maintenance purpose, and you find this most where nearby to the tank. For example, if I'm having a roof tank over, and if I need to cut down the complete water supply just for the maintenance for the complete building, I'll be having one valve over there. Yes or no?
Sir, even inside the toilet. Sir, even inside.
Or else I can say, for example, nowadays in modern plumbing, what they are doing, individual bath in the riser,
Yes, sir.
having one valve over there. That is a ball valve, I can say, or a gate valve. Okay, why? Because, for example, it's not recommended. For example, if it's a high-rise building and it consists of like 10 bathrooms and like 10 kitchen areas, for example, in that building, it's not recommended that I totally disconnect the complete water supply just for one person who's suffering, right? So that would be open from the top. Here I'll be closing it. That means no water supply in this particular wet area, so that we can proceed with our work, isn't it? Yes or no? So different risers for this line.
Yes,
So likewise. So as you said just now, so we can see, if you observe this, you'll be seeing different valves nearby to the toilet. That means I can cut down the water supply in this area and we can go for the maintenance. So always remember, this will be always open whenever we need it. When that only at that time only we'll be closing this, isn't it? So completely open and completely closed. But if I try to lift like half open and half closed, if I had done that, you know this, because it's not a regulating valve, it cannot bear that much of pressure. The gate inside this will be damaged because of the excess pressure. It is not having this capacity or tendency to bear that much of pressure. But when compared to ball valve is somewhat higher when compared to this, because it's having a cross section kind of C kind of thing over there, or what shall I say, a kind of scoop. You have seen online scoop. What is a scoop? Where we carry ice cream, where we try to take the ice cream. For example, if I'm having a brick over there, how we take ice cream in a scoop, right? So how exactly it looks like, it's kind of same thing, ball valve. So it can be partially open or partially closed, but not recommended. But because of gate valve, like this flat surface, directly hitting, damaging. But as per this curvature, I mean the curve over here, we'll be having somewhat regulative attacks, but not again recommended. That why they are using nowadays, because the life of this is, when compared with that, is more. So that's why nowadays ball valve we are using rather than gate valve. Both are IVs only. So now we are using ball valve. So, but the thing is, both are IVs, isolating valves. So now this was about the gate valve. So gate valve has rest resistance to the flow and should always be fully open or fully closed purpose. Now globe valve, where do you see globe valve online? For the higher flows. Yes or no? And anyone has seen Swadesh, they can identify. No one has seen
Yes, sir.
Swadesh movie, man. Right there. So this is a globe valve where you can regulate. It's a regulating valve for a higher flow. For example, this inlet and this is the outlet. So water comes like this. Again, same function, but for the bigger flows. When I open or anti-clockwise, if I rotate this, this will be coming up, and it allows the water, for example, like this and going like this. Okay. So I can adjust or regulate the flow as per my needed. And if you remember, they check on the other side that how much pressure it's been required. For example, they were generating electricity. So as per the need or as per my the pressure required in the line, I can adjust. That's a regulating valve, isn't it? So this is used for the higher flows, or the bigger flows, and this. So this is a globe valve over here. So globe valve is different from a ball valve. It is a type of a valve used for regulating flow in the pipeline, consisting of a movable disc type element and a stationary ring, and seated in a general spherical body. This is commonly seen. Do you use this in plumbing or HVAC mostly?
HVAC, sir.
In firefighting, no?
In firefighting, I can see, but in HVAC.
Yes, for the higher flows. Okay. Next is the angle valve. Now this is the same valve which has been, you can see, or the principle in this is what, where you see below the laboratory, and this is again the same valve is being installed in the faucet, what we have discussed. Yes or no? For example, if I slightly tilt, I'll be getting the pressure required or more than enough for me to serve the purpose. And why we are using one more thing is that just to what online? Save the picture. I mean the faucet over there. Because example, if you think, for example, the water is coming from like 30 feet or 40 feet of the height, and it's hitting to that laboratory. For example, if someone is calling, so that faucet might be damaged or that fitting might be damaged. Yes or no?
Yes, sir.
So we are regulating the pressure for that faucet from here, isn't it? So first this will be getting damaged and that faucet, because that is much expensive when compared with this. Yes or no?
Yes, sir.
So this is
even with Muslim showers.
Which one?
Even with Muslim showers, we always use angle valve.
Muslim shower?
Yes, which is used with the WW.
No, I didn't.
Hand shower.
Hand shower.
Hand shower, you can see.
Yes, yes, yes.
Yes.
Yes. Okay. Manually operated valve with its outlet opening oriented at right angles to its inlet opening, used to regulate the flow of a fluid in a pipe. As you know, this as a regulation valve, angle valve. Now PRV, this is very important, pressure reducing valve. So now let's see what exactly PRV stands for. That's a pressure reducing valve. The name itself is saying that it is a valve which reduces the pressure. But how? Whenever the fluid flows by this or passes by this kind of valve, the pressure, it reduces. How and why this is being used? As per the standards like IPC and UPC, first of all, they says this, and where we'll be seeing this pressure reducing valve is in the risers. Okay, for example, I'm having like 30 floors of the building, just an example, and the water is coming from the 30 floors of the top of the building and it's coming down, and I'm having all that's completely residential, you can say. And on every floor, we are having like wet areas like bathroom and the kitchen areas. But the problem occurs when the pressure is coming down, it increases more and more. So as per the standards or as per the codes like IPC and UPC, they say that it should not increase more than 80 psi and it should not increase more than 60 psi. So 80 psi is being set by IPC and 60 psi is being set by UPC. So now whatever the standard your company is following, whether IPC or UPC, you need to check in the riser, in a vertical pipe in short, whether the water which is coming down, it should not exceed. For example, on the 30th floor, if I came across 29th or sorry, from the 30th floor, the water is coming down. And if I check on the 30th floor to 25th or 24th floor, I got there is like 90 psi. So I need to check before that floor. For example, I've checked on 27th floor. Okay. And I got, okay, here is like 59. For example, if I'm dealing with UPC, so I need to install one PRV over there so that the water becomes zero over there. Again, it what happens? It crushes the energy over there. I mean, it's a kind of plunger over there. I mean, a kind of, what should I say, spring over there. It comes and it balances and it tries to break the velocity over there or the gravity pressure And again it starts from 0. So we need to measure this where I'm getting 60 and 80 psi as per the standard. So there are different standards, different values over there. So mostly is 80 and 60 as per, because mostly used is IPC and UPC. So we need to check this and we need to install one PRB in the riser. The reason behind to install it over here, because there will be no excess pressure. This says that the UPC and IPC, the codes, the standard value, why they're saying this, it is being sensed by them that if the value does not increase as more than 60 and 80 psi in that particular height, in that particular floors for that, so that is sufficient enough, or that is more than enough, or it's not excess pressure that will be damaging the fixtures. Getting my point on? Yes or no?
Yes, sir. Yes, sir.
Right. So that's the reason we are cutting it down, the pressure which might cause a problem in future to the fixtures, we are cutting it over there. But still we have some precautions. For example, angle valves and all this, just now we have said you, I mean the laboratory. Yes, please.
Sir, I have one question. Sir, if the building height is 137 meter, so how many PRV we can install?
Is building height is?
137 meter.
We'll do it now. Okay, don't worry. No,
Okay.
I have an example. We'll be doing it now. Okay.
Sir, can you please tell me again this pressure values?
Yeah, it's there, Fahad. Don't worry, it's there below. Okay. Following Fahad.
Okay. Okay.
Right.
Sir,
So it is used.
what does it mean? 80 psi.
Pressure pounds per square inch. We'll be seeing one example. We'll be seeing one example now.
I mean, yeah. Okay. Yeah.
It is used to reduce the pressure in order to maintain the life of the pipe. So, as I said, velocity plays a major important role in a plumbing, because if you deal up with different types of flows, we'll be seeing that also. We do have two types of flows. One is turbulent and one is laminar, right?
Laminar.
So laminar is what? Smoother. Turbulent is what? With high velocity. So high velocity with the bigger diameters of pipe, not recommended. We have maximums. Laminar or turbulent, we'll be seeing that. So if the velocity inside the pipe is higher, what happens? We know this, the life of the pipe or the material will be getting reduced for sure, isn't it? Yes or no?
Yes, okay.
Now, this valve reduces the pressure of the water that goes through it or passes through it, you can say, and is used to obtain a regulated and constant value at its outlets. That means I can say, yes, we have regulated the value and it's within the range. So I'm not having any problem. I can say yes. Constant in the sense it is within the standard, like either if I'm dealing with 80 or 60 like IPC or UPC, I am pretty sure because we have done the calculation. We have fixed one PRV over here because I've calculated, okay, here is 60 and here is 80. As per that I have done. So I'm pretty sure in this particular length of this pipe in this vertical here in between, this is 60 or 80. So I can say it is within the standard, not constant, you can say within the standard over here. It is installed at the water means, that is the rises for the high-rise buildings. So this is used in the high-rise buildings. And water means, that means in the risers it's being installed. It protects the whole installation problems due to excess pressure, which is causing pressure noises in the pipes. That means noises in the pipes. Have you heard? No? Anyone?
Yes, sir.
This pressure will be causing noises in the pipes, then water hammer, then splashes. What is this water hammering? What is splash and all this? We'll be seeing it now. Okay, for example, this is pressure reducing valve. You can see the strainer and all this. For example, the water enters. You can see this inlet and outlet. It goes over your strainer and it compresses over. You can see this. This try to compress the spring, and again, what happens? The pressure tries to minimize or minimal, then it will be going down. Okay, so what is happening whenever the water has been passing by? What is happening? It is reducing the pressure, isn't it? Then it is neutralizing, then it is allowing. Okay, so this is how exactly a pressure reducing valve look like, and why and how it is being installed as per the calculation. We'll be seeing it now, inshallah. So always remember, if you're dealing with IPC standard, you need to check where you are getting the pressure in the line as 80 psi, and as per UPC, you need to check where you are getting the pressure as 60 psi. You need to install one PRV, or you need to show in the line diagram, okay, here we need one PRV over there. Okay, now for this, have you people read in plumbing, firefighting, pressure exerted at the bottom, one liquid column of height? Anyone? Have you people read in the firefighting that what is the pressure exerted at the bottom in one liquid column of height? Anyone? Has sir, you people reached over there or no? Pressure exerted at the bottom, P is equals to
rho GH
0.433 psi, H into 0.433 psi
into height.
No. Okay, don't worry. If not getting, it will delay. It will not rush. Okay, we'll discuss that. For example, everyone, just see it over here. There are a number of things over here. Okay, so now let's see this project over here. So let's read first of all this project. So this is basement 2, basement 1, ground floor, first, second, and then so on. This is 14th floor over here, 30, 13, and 14. Then still it's continuing the same, 14 and 15 and so on. And I'm having is like 30 floors of the building, and I'm upper roof. I'm having this one tank over here. So now if you see this, there is one water line coming down. This is called as a gravity line, what you're seeing. Okay, this is a gravity line. Why I can say gravity line? If you can see this connected to this header to the tank, and it's coming down, and you can see this is being serving to this what line? Online, the branch coming out and serving on this floor, and so on. Now this is what a PRV looks like, the same kind of spring and all this. So this is the pressure reducing valve. So now how it works, we have seen. Now what, why they have installed it over here. So now for example, this project for some XYZ Gulf country. So now let's see why they have installed over there, and let's find out that whether they are dealing with IPC or UPC. So I need to find out at the point here, like example, this midpoint, what is the pressure acting over here? Because there might be pressure acting, like example, this much of pressure. For example, as the water coming from here, as it comes down, the gravity pressure increases.
Yes,
The
sir.
more it's coming
Yes.
down, it increases more and more, more and more. So what do people think? For example, this 30 floors of the building, if I'm supplying till this floor, like ground floor or first floor. So what do people think? The pressure will be increasing 60 psi or 80 psi or more than that? Very huge, isn't
More
it?
than that.
More than that, right?
Yes.
So you can
Yes.
see there are n number of PRVs. Okay, here,
Yes.
Umair, follow. Your doubt will be
Yes, sir.
clarified over here. Okay, so there's one more PRV over here. Okay, and further one more PRV, one more PRV. I'm not having any PRVs over here because I'm not getting the pressure what is required. For example, required in the sense I'm trying to say that that is within the range. If it is exceeding more than the range or as per the standard, what code we are following, again I need to install one PRV over there. So now I need to find out the pressure exerted at the bottom.
Yeah.
That means what is the pressure acting over here? So what is the reason they have installed one PRV? That is the pressure reducing valve. So if I try to find out this, then I can say this. If I'm getting the value nearby 60, I can say this. They are dealing with UPC, or if the value is getting by the nearby to 80, then I can say it's a IPC, isn't it? And if you
Yes.
want this reference, I can give you also, but I'm not remembering. I have this code with me. If you want reference, like it's been clearly mentioned in the code. Just a minute. If you want reference online, do you or no? I'll give it tomorrow. Exactly. I'll find out. I'm not remembering.
No
I
problem.
think this or some
Sure.
code, but we are having it clearly mentioned because you can say that if someone is asking, yes, it's been given from this code and it's been clearly this, for example, this table number and the chart or whatever. We can say the code and page number so they can find out with the year and all this. Just for the information and reference, because I said, nah, anything is something we don't just say it. We need to just check and say that, okay, yes, this is again used for, we need to give some kind of references also so that they accept, or else they don't. Okay, just let me just read it over here. I think here it's inside. This is fixture estimated demand. Okay, nothing. If you read it over here, assume an office building of 4 stories and basement. Pressure on the building side of the pressure reducing valve of 55, that is PSI, after allowance of reduced pressure fall off at peak demand. An elevation of height above, an elevation of highest fixture above the pressure reducing valve of 45 feet, a developed length of the fixture. Okay, not exactly it's saying, but I have it. I'm having it somewhere. Inshallah, I'll try to find it and let you know, inshallah, in tomorrow's session. Okay, everyone. So
No
as
problem.
of now, just to
Okay.
remember, find out the pressure exerted over here, we're having a formula: pressure exerted at the bottom of one liquid column of height, that is P equals H into 0.433 psi, where P is nothing but the pressure, what we are here to find out, and H is nothing but the height. Okay, equals in terms of feet, and 0.433 psi is the standard, or standard you can say, and that the units is psi. That means where I can find out the thing in terms of psi. So first of all, I need to find out the distance over here, or the height or the length over here. Then I need to put into that. But there is some conversions because here these things are in metric, that is millimeters I need to get. So I need to convert that into feet, then into what? Guess online. Okay. For example, DI. First of all,
Yes.
you people write it. P is equals to H into 0.433 psi. That is pressure. To find out the pressure exerted. If you're not getting, I'll say you one simple example online. Just see this. There's a water bottle in my hand. Okay. For example, if this is completely filled, here will be the most acting pressure, isn't it? Because this complete load is over here, isn't it? Yes or no on this base? Yes or no online?
Yes. Yes,
I'm here to
sir.
find out what is the pressure exerted or what is the pressure acting over here in terms of PSI. If it's like 80 or 60, again, this bottle is further continuing. For example, here, I need to install one PRV over here so that it becomes 0. And again, if it's like 80 over here or 60, again, I need to install one PRV over here. To find out the pressure exerted at the bottom of one liquid column of height, the formula is P is equals to H into 0.433 PSI, where H is nothing but the height. Okay. And 0.433. Sorry?
Sir, P is equal to H.
P is equals to H into
H into
0.433 psi.
and 443 psi.
0.433.